Hello and welcome back to the Cracking Fang YouTube channel. Today we are doing part 2 of my Meta Product Architecture Interview Guide. In the first part, we talked about what a product architecture interview is, how it differs from a system design interview, what the structure of this interview is, what the evaluation criteria is, and also how certain levels might respond to these types of questions. Now, in part 2, we're going to be doing a sort of mock interview where I go over one of the kind of leaked questions and how I might approach it. I want to make a few things clear off the bat. The first thing is that this video is for information purposes only. It does not attempt to fully answer the question provided. It simply serves to bring awareness of the things you need to be discussing in these types of interviews. The second thing to note is that there is no right answers to these questions. Everyone's approach will be different, and that's fine. Please don't cargo cult the answers or approach in this video. They're not enough to pass a real interview. I have consciously not given everything away because otherwise you'll never learn to think for yourselves and you won't pass this interview. I also purposely left holes in my approach and my design in order to stimulate you to think about where you can further expand. If you finish the video and you come away with questions like, he didn't talk about X topic, what about Y technology? Or you could have done Z and gotten a better result, then I have successfully achieved my goal here. If you still feel like you don't understand this interview and you want more hands-on coaching, then you can always become a channel member at the mock interview tier, and we can go through in a private setting one-on-one to help you with this interview. Okay, that's enough. Let's now actually get into it. Okay, with the introduction out of the way, now let's actually jump into the content of this video. The question that we're going to be solving today is design an online code contest platform similar to HackerRank or LeetCode Contest. So let's see, design LC contest / HackerRank. So obviously the first thing that you want to do here is talk to your interviewer and actually figure out the things that you need to be implementing here. Obviously, in this example, we don't have an interviewer. I'm basically just doing a monologue and talking with myself. So let's just get a few kind of basic assumptions down from that our interviewer would typically give us. So what's it going to be? So users will participate in a weekly contest, and there's going to be 3 questions per contest. Okay, what else would the interviewer tell us? There will be unlimited time per question to submit your answer. Obviously, it needs to be within the week, otherwise it won't count for the contest. So we now know that, and then we also want to be able to, okay, so you can solve the questions in the contest, and we also want to be able to view a leaderboard in real time, so we can see how people are stacking up in real time. Now, another thing we want to consider is that a question is considered passed if all the test cases for that question pass, right? So if you pass all the test cases, that's how you know that your solution is correct. In terms of traffic, we expect that per contest at peak time, there'll be about 10,000 people submitting solutions. And then something else we want to do is we also want to be able to view historical contests and their results. So the leaderboard for those contests. Okay, so these are kind of the things that we want to do here. This is your interviewer would give you this prompt, and it would be up to you to ask some questions here. So obviously we have at a base level, we need to design some platform where you're going to be able to do a weekly contest and submit some sort of code for this. And then one of the requirements here is that we need to have a leaderboard in real time. So we'll have to figure out how to do that. And then, how to handle the rest of these requirements. So again, there's a lot of questions you can ask here. I'm purposefully not going to go over every single question because it would just take too much time. And it really is depending on you, how you want to design this system. So now that we know that the kind of basic things that we want to design for, let's now go to the next part. And I'm going to skip doing the capacity estimations because frankly, doing the math is just not really worth the time, but at this stage, you'd probably want to figure out the capacity. Sometimes the interviewer wouldn't tell you, you're going to have 10K people submitting, you might have to pry that out and then calculate the actual queries per second or memory egress and ingress based on the payload size of the question. Anyway, I'm going to stop rambling on that one. At this point, we can go to the next stage, which is to kind of think about what the SQL models we would need here be. So the SQL models for our database. So we're going to need basically 4 models off the bat. We're going to need a user model. And what can we have here? We can have the ID. We can have their username. We can have the date created and some other metadata. Who cares? Other metadata. Okay, so that is the user model. And, we'll just have some information there. What other models might we need? Well, obviously, each contest is going to have 3 questions or 3 problems to it. So let's just have a questions model. And similarly, this one's going to have an ID. Maybe it might have a title. It's going to have some other metadata. It's going to have the contest ID that it's associated with. And this will need to be a list of IDs because you can actually have one question be reused potentially. So actually, this is something you could ask your interviewer. So maybe I'm giving you guys a little bit extra here is, can a question be used for multiple contests? That's something you might want to clarify with your interviewer. So let's see, let's go back to our thing. So you have the contest IDs. So they may tell you, no, you can't reuse a question. Yes. So these are things you might want to clarify. Again, I'm not giving everything away. I want to stimulate you to think about this. Okay, so now we have the contest IDs, and then we also need the test cases for a given question, right? So for a given question, you need to have test cases which are going to run, right? And test cases is going to be a list of a test case model or object, and we'll define that model in a bit. So we have the question, and you could have other fields in here depending on what your interviewer wants to see. They may probe you to add extra metadata fields here. Okay, so let's see what another model we might need is. And obviously we need a contest model to store each contest. So each contest is going to have an ID. Maybe they'll have some unique name. They'll probably have a start date, an end date, and then some other metadata. We're not going to concern ourselves with that. And then for each contest, there's going to be question IDs. Obviously, this is going to be a list of questions, and these are the questions for that particular contest, and there should be 3 of them. So this would point to you join here on some sort of ID. Okay, so I seem to have ran out of space here, so let us just drag this down and let's do our last model, which will be the test case model. So obviously each test case will have its own ID. It's going to have the question ID that it's associated with. And then we could basically have the input value for the test case and the expected output value, and maybe some other other metadata. So that is the test case model. Again, there can probably be extra stuff here. Let's see. So the test case is linked to the question. So for a given question, you could see all of the test cases. So that's how kind of you would join, and then somehow you can link in the user model. I'm not going to focus too much on how the user model will go in, but most likely it's going to go into the contest, or you can store on the user model the contest that person has gone into. But for the purposes of this video, I don't really want to dive too much into that because frankly, it's not that important, and we want to actually focus on the design. So just to recap, we've had our user model, our question model, contest model, and test case. Those are kind of the 4 main data models that we need for this problem in order to make it work. Now let's actually go and draw out what our system might look like. So let's just go and make some more room over here. And then let's go get our pen. Okay, so obviously we are going to have clients, right? So these are going to be people who are accessing our contest. So these are going to be the clients, and these are just going to be people who use our site or product. Oops, why is this not pasting? There we go. These are just going to be users, and users are going to be interacting with our service. So they're going to send requests, from the UI, and they're going to interact with our page. And we're probably thinking ahead, we want some sort of rate limiter here to make sure that people don't spam the contest or somehow send too many requests and try to overload our server. We want to make sure that everyone's playing fair and there's no kind of dirty business going on. So we're going to slap a rate limiter here. And we can talk about how to handle bad actors later, but for now, let's just say we want a rate limiter to make sure that people aren't sending our server too many requests. So we're also going to need a kind of web server just to handle everything. So this is going to be our web server, and this is going to handle all the logic, right? So the user submits their code, and then the web server needs to figure out what's going on there. So we're not going to talk too much about what's going to happen inside the server. Let's just continue to actually draw out our diagram and see what else we need. So obviously we're going to need a database here to store our information. So let's just say that this is our DB, and this is where we're going to store most of our information. Now, if you think back to our requirements, we need to view a leaderboard in real time. Thinking ahead, if we just insert into the database and then try to, every time we want to show the leaderboard, to recompute who's actually first in the leaderboard, this is going to be too slow because the database query, it may not be that efficient to insert into it, and then querying it for the top user, if we have a lot of data, is just going to be too slow, and we're not actually going to have a real-time leaderboard. For this reason, we want to use some sort of in-memory DB to basically store all of the results for a given contest, because we know that contests typically last, we know that they last for a week, right? So for that given week, we can store all the information of our in-memory database, so that way we can quickly query through the top users and the top ranking. We can insert people's submissions into there, so that way we can easily keep a rank, and that way we don't need to actually query the database. And eventually, once the contest ends, then we can basically just start writing all the information to the database, or we can write to the in-memory and then write to the database. Either way, the in-memory will support that current contest. Because after the contest ends, we don't need a live leaderboard. It doesn't make sense to have a live leaderboard for a contest that's not going on. We can just read from the DB, and that's fine. And then we can cache the result. So we don't really have to worry about that. Okay, so that's enough on this part. Of course, you can always talk a lot more about these components, but again, purposely not going to go into the full details here. All right, so we also have another element here, which is actually, okay, so people submit their code to our web server. Now, how are you actually going to process it? So obviously, you're going to need some sort of worker queues to actually run the code that they've submitted and actually make sure that it spits out the right result. And obviously, you're not going to want to do that on the web server itself. You're probably going to want to shunt this off to some microservice or some worker nodes to handle that for you, so you don't bog down your main server. So for this reason, we're going to want a, a message queue. Message queue. And what this message queue is, basically, users is going to submit their code that needs to be run. It's going to create a job on the message queue, and the message queue will then send that off to one of the worker nodes, which will actually execute the code in the kind of language of choice. So actually, this brings up a good thing, which I didn't mention earlier. And obviously, this is one of the deep dives of the question, and this is why I didn't want to give out too much. But okay, one of the things, obviously it's a coding contest, but there's multiple programming languages. So how are you actually going to support all of these programming languages, both in the SQL model side and also for your actual server? So that is one of the deep dives of the question, and I'll leave that one for you to kind of think about. But do know that obviously there's a ton of programming languages out there. Do you make the decision to maybe cut it off to maybe just the top ones? Maybe you only want to support Java, C++, Python, and there is a trade-off here. Obviously, then you need less machines and less, run times to actually execute these different languages, which is simpler for you to implement, but then your users may not be happy because actually my favorite language is not considered here. So you need to make that trade-off, right? And this is where in these interviews, you're actually tying it back to the user experience. You're not literally designing the system and how it's going to work. You actually need to think about the user here. So we have a potential trade-off, which I guess let's just kind of discuss quickly. So we have the trade-off of, let's see, language trade-off. Oops. How to support multiple languages, right? Cap the number. This might be unhappy users if their language is not supported, but supporting all languages is difficult and needs a lot of machines and DevOps to actually make sure you can execute all of these things. So this is one of the trade-offs. This is a big part of the question. So I'm going to leave this one up to you. How would you handle multiple languages, right? Now let's get back to the actual design here. So we have our message queue, and this is going to fire off jobs to the actual workers. So these will be our, let's see, worker nodes, and these will actually execute the code with the given test case for that question, and then kind of return the result to the web server, and then the web server will return that to the client. Basically, did they pass the question or not? So this is kind of like our basic design here, right? Just to recap, we have our clients who are using the system. They're on the UI, they're typing in the code for their question, they click submit, they go to the rate limiter, make sure they're not somehow spamming our server and then forcing us to process too much. We probably want some sort of rate limiting here to make sure that bad actors don't get through. The web server is going to receive the request. It's going to create a job in the message queue, and that message queue will basically send that to a worker node to evaluate the code against the test case for that particular question, check whether it matches. It's going to return that response to the web server, and then based on that, we can basically determine, okay, we probably want to update our in-memory database such that, did the person answer the question correctly? Okay, maybe we want to increment their score by however many points that question is worth, and then that will update, our leaderboard, because for our in-memory database, we probably want something that's like a sorted set. So you could potentially use Redis here and use one of their sorted data structures, and that way we could easily have, a sorted list of the rankings for each person, ranking, and that way if we wanted to basically find someone, it's a sorted set, so we can find it in big O of one time, because we can find that element by the key, which is probably going to be the ID. And then also if we want to insert new additions, we can do it in big O of log n time, because it's a sorted set and it's just kind of going to handle all of this for us. So anyway, that's kind of like the ranking part. And then, we want to store extra information into the database, and then obviously the web server is going to return the response back to the client. Did you answer that question correctly or not? And from there. Okay, so from here we have, let's just recap. We went over kind of the high level of our question. We talked about the SQL models we want to see. We also talked about a potential trade-off here, which is, okay, how do we want to handle the language trade-off, where do we want to support that many languages, and kind of some trade-offs associated with that. And then we talked about the basic design. Now let's kind of take a step back and now actually focus on kind of the user experience. And we also actually need to talk about the kind of APIs that we'll design. So let's kind of think about the APIs that we need for our system here to support this. And of course, this is not going to be an exhaustive list. This is just going to be some of the main APIs we need to do. So let's think about this. Well, obviously for a given contest, we need to be able to get the questions. So for a given contest ID, and maybe you need to authenticate yourself with a user ID and some other metadata, it's not particularly important. You're going to get the questions. So you're going to get a list of questions, and now the client will actually have those questions, and then you can render them on the UI. Let's see. So we also need to be able to submit a question. So we're going to submit a question. So you're going to need to know which contest you're submitting for. You're going to need to know the ID of the question you're submitting for, the user that's submitting it, the actual code of the submission, and perhaps the submission timestamp. So there's actually two kind of important things here. Oh, and maybe let's talk about the response. I don't know, perhaps we could return a payload that looks something like, I don't know, success, and this would be a Boolean, did you, or let's just say passed, or accepted, let's say accepted. This is gonna be a Boolean. And then perhaps if it wasn't accepted, this will be like, so test cases, test cases failed. This could be a list of, I don't know, the test cases that you failed. Now, again, there's actually some trade-offs that we need to make here, and kind of let's think about some of them. The first one is that we're actually choosing to submit the timestamp, which will be used for ranking. And the reason that we're opting to do this is because we don't want to wait for the actual server to process the thing and then use that as our timestamp, because it could just happen that a user submits their code first, but because in our system, maybe the message queue gives it to some worker node that's actually a little bit backed up, or it doesn't process it as fast, or maybe it's a slower language, we don't want to give it to the first person whose code actually runs and is confirmed. We actually want to give it to the first person who submits it and gets it right. So that's why I'm thinking maybe we should use the submission timestamp here, so we can honor the first person who actually submitted something that worked, and we can do that. Obviously, there are considerations here. For example, I don't know, what if you somehow manage to spoof the timestamp, or you do something funky with your computer's clock to make it look like you submitted earlier than you actually did. So this is a trade-off. There could be some bad actors here who've done something to basically spoof the system into thinking they submitted earlier. But then also we want to, whoever actually submits their code first and that submission is correct should actually be the first person who kind of gets the credit there. So again, it's a trade-off. It depends on what you want to do here. All right, the next thing is this code string. So obviously you're going to be sending over the code to the server such that it can run it in the language of choice. Actually, we also need a field here. How do I get my color? We also need a field, which is going to be the language, because obviously based on the code, you probably won't be able to tell what why can't I type? Click, please. Okay, anyway, let's just say language. So we want to actually know what language it is, so we know how to execute the code. Otherwise, who knows what we're executing it against. You'll notice that we have the code string here. And now this is another thing we need to be careful of, because again, people can be assholes. What if you try to somehow inject like a SQL injection here, right? Drop table questions, right? How do we make sure that people don't paste crap into their code string? So perhaps we can actually handle this somewhere on the web server, where the web server can maybe try to parse out any kind of invalid responses. Maybe we do this on the client, but perhaps that might slow the experience down for the user. So it's a trade-off. Okay, do we want to sanitize the strings on the front end and have all these regex checks, which are checking for things while the user is coding? That might actually degrade their experience, because presumably they're using some sort of like web UI. And if they're having all these checks run, like, oh, is it contains this string, or does it have this regex, that might slow things down and give them a bad experience. So maybe we want to shunt that off to the backend to handle. Another thing to consider is that, okay, what if someone's just an asshole and they paste in the text of Lord of the Rings and it's a huge string, what's going to happen when that gets to the back end? Or someone purposely introduces a memory leak. Say they're writing in C or C++ and they just have a memory leak, or they purposely do something that's malicious. So these are all things that you need to consider. You probably aren't going to catch that on the client side, but you might be able to do it on the backend side. So just know that there are risks associated with taking the string, and there are things that maybe you want to have a separate kind of service that runs in your backend, which actually looks at these things and makes sure that the response is correct. Okay, let's see. So that's the submit question. Is there anything else we want to do here? So that's probably fine. Let's kind of get back on track. And then the next thing, we probably want a fetch leaderboard thing, which just takes the contest ID and then returns a, list of a response, which might have the user ID and then their ranking in the leaderboard, and then like the score they have for that particular contest. So we could have a payload like that. Another thing, which I'll leave it up to you to actually think about, is how do we want to fetch this leaderboard? If we want it to be real time, we probably don't want to be hitting the server, repeatedly, because you might have to refresh the page. If it's really real time, perhaps we want some sort of WebSockets connection or long polling or some other method such that we can actually get real-time updates from our backend, which is going to actually fetch this leaderboard. So perhaps also we might want to introduce a separate leaderboard service, which is constantly updating the client or always has the top leaderboard kind of stored, so we can give it to the client when requested. So these are kind of the basic APIs. I'm sure there's more you could have here. If you want to view historical leaderboards, we could have that as well. But these are just kind of the basic ones that you'll want here. Okay, so I have been blabbing for quite some time now. Let's kind of take a step back and maybe think about kind of what the UI could look like and how certain user actions will kind of interact from the client side to the server side, and also kind of what our design decisions, how they might affect the user, and can we kind of adjust our design to accommodate these if we feel it's necessary. So let's now take a short pause and do that. Okay, so we just talked quite a bit about the question itself, the database models we might want, what the system could look like in terms of the overall diagram, and what some of the APIs could be, and also some of the kind of trade-offs, and we've been talking a bit about them as we go along. Obviously, you're designing a product here, and products are typically user-facing, so now let's also talk about the UI and what this might look like. So let's do kind of the most basic one first, which is going to be the leaderboard UI. So this could be one of the pages. So we will basically have a table here, which is going to basically rank the users, right? So let's see if I can copy and paste this, save some time. So this will be our kind of table here. And okay, I don't want to waste too much time actually drawing this out, but you get the idea. So this is going to be like the rank in the leaderboard. Oops, rank. This will be like the user. This is their score. Oops. And then I don't know what country they're from. Who knows? I think LeetCode has that. I don't know. It doesn't really matter. So this is kind of the leaderboard one, and obviously, like we said, do we have the fetch leaderboard API, which is going to get this for us. Obviously, if this is a real-time contest, so it's going on right now, we probably want all of the data to be stored in memory such that we can fetch it quickly, we can update the leaderboard quickly and efficiently. We don't want to be querying the database all the time, because that would be inefficient. We can't really cache results because the leaderboard is always changing. So we need to be basically in memory so we can do it on the fly and in an efficient way. Obviously, for this one, I suggested we use something like Redis, and perhaps the data structure of choice could be a sorted list. That way we can easily basically keep the ordering of people, easily update their scores, fetching them in constant time, and then we can update the sorted list in log n time, whereas God knows what it would be if you tried to do it in the database itself. So that's kind of like the fetch leaderboard. Obviously, this is the kind of simple part. There's really not too much here. Obviously, the deep dive here is how you would actually set up the data structure to actually calculate this. But we're kind of talking about the UI now, and I will kind of leave the implementation details of kind of the leaderboard for you to kind of research and figure out what are the best options, what are the trade-offs with each one. Obviously, the main trade-off being that if we don't do it in memory, then the experience is going to be really slow, and we're probably not actually going to have a real-time leaderboard because fetching from the database is too slow. Okay, so that's kind of the leaderboard side of it, and this is not really the interesting part. What we want to focus on is actually the kind of UI that the user is going to be facing when they're actually interacting with the contest itself. So if we kind of think about it, we'll have this page. Maybe at the top it'll be like the contest name, and we're gonna have some name here, and then we're gonna have some like tabs where you can switch through each of the questions. So this will be like question 1, this would be question 2, and this would be question 3. Obviously, when you click on one of these, so when clicking changes question, pretty straightforward, and then this part is going to be maybe the language selector, and maybe a user on their kind of profile can actually set this ahead of time so you don't enter the contest and then have to set your language. You probably want to set this ahead of time for a better user experience, because you don't want to be wasting some time to actually switch your language. It's not going to be nice, right? If you set it once, it should be stored somewhere on your kind of preferences, and then you have that. So a little bit more on kind of the user experience there. Okay, so obviously in a contest, code contest, you're going to need a code editor. So this is kind of going to be your code editor. And, if we kind of think about what a code contest might need, obviously you're going to need to submit your code. And then, so this is going to be the submit button. Submit your code. And as we know, we defined in here, we did a submit question. So we're obviously, once you click this, we're going to submit a question, right? And then optionally, we might have some test cases which are provided to the user, and we might want to allow users to actually test their code locally if they want to basically run against the test cases. Obviously, the top users probably won't use this because they're super geniuses. They don't need to run their code. It's just going to be accepted first time every time. But it's something we want to have. Probably for the people that are actually going to be winning the contest, they're not going to use it. But for normal people who just want to kind of test themselves, this might be useful. So we might want to involve a kind of run button here. Now, this UI is pretty straightforward, but there's actually a lot of things behind the scenes in terms of user experience that we can think about here. And there's, some trade-offs. So let's just discuss those a bit. So the first thing I want to talk about, and I think I alluded to this before, is that, okay, we have this code editor. What happens if people are assholes, right? What if the text is too long? What if you just paste a PDF in there and just YOLO submit it, right? Do we want to control this on the front end, or do we want to do it on the back end? So obviously this is a trade-off, and okay, I don't have much space, so I'm just going to talk about it. Right, if we have all these checks on the front end, then this is going to slow down the experience and potentially could actually introduce lag into our system here, because if all of these checks are running, okay, is the length too long? Is this string present in the text that the person has edited? Have they written drop table, or have they done something malicious? If we're running all of these checks in the background on the client side, this might actually degrade the experience, and the user might experience lag when they're typing, and that's going to be not pleasant for them, right? Like everyone hates when you type and for some reason it's not instant, right? We expect as soon as we type a character to see it on the screen. If there's a bit of a lag, they're going to be like, this is shit. So we want to make sure that we move as many of these checks to the back end such that we don't degrade the user experience, because if there's lag or there's high latency between typing something and actually showing up in the editor that they see, they're going to have a bad experience and may not ever use our product again. So we want to make sure that we do as much of that on the back end. So maybe we can just check that the text is too long here, because that's pretty simple. You just call string.length and then check, okay, is it greater than some amount of characters? We probably expect the solutions not to be over, I don't know, let's just say 500 characters for each question, maybe 1,000 for some people that do it in a really unoptimized way. But yeah, if it's like 100,000, then we know that something is clearly wrong there. So that's the first consideration is, text too long or just bad actors, right? Bad actors, drop table, someone does a SQL injection or something dodgy. So what else do we want to consider here? So obviously when you click the submit button, you're going to submit your question to the backend, and it's going to run it against the test cases on one of the worker machines, as we kind of talked about in our design, right? You add it to the message queue to basically queue it for processing, and eventually it's going to get processed by the node. And obviously, hopefully this should happen quite quick, because you don't want to be just sat waiting there a long time for your question to run, right? We probably want to make sure that you get a response relatively quickly. I don't know, maybe, and we can say maybe we want like a 10 second response time max from the server to actually tell you whether or not you passed the question. So that is something that can consider. And this brings in the question of timeouts, right? Do we just tell the user that they timed out, or we tell them that all the test cases failed? That's something that perhaps you can think about. But basically, when you submit a question, I guess there's a few kind of things that can be returned, right? Either you passed and all the test cases work, you failed a test case, or failed test cases, test case, so you failed them, or maybe you timed out, right? Because it's possible that your code sucks and it's really inefficient. Maybe you did like 4 nested for loops and you wrote a big O of n to the 4th solution when you can actually do it in big O of n time, right? So you're going to time out. And we probably want to define what a good timeout is, one, so that users can get a response quickly, and also that our machines here, right, if they're waiting for this to process, and we don't have an appropriate timeout set, then one worker node can actually just get stuck waiting for one person's shitty code to run and then back up our entire system. So we need to have an acceptable timeout mechanism defined to actually do this. So this is probably something that you'd ask your interviewer about, and obviously you'd probably do this at the beginning of the interview, not at the end. In this example, I have the power of 2020 vision to basically just, I forgot to talk about this in an interview, probably not. But anyway, so we probably want some sort of like timeout value. So this is just something to think about. And, another thing we want to consider is, okay, you get the test cases that you failed, but do we want to do this? For example, if someone passes all the test cases but one, what is stopping them from just hard coding that test case here and then they pass all of them, right? If we tell them the test case they passed and the output that we expected, then they could just hard code if, input equals this, output that, and then bam, they've now done it. Granted, they're not going to win the contest with this, but they are cheating. And that brings the question of, how are we going to handle cheaters? Do we care about people who aren't really winning the contest if they cheat? Like whatever, if you just want to copy someone else's code, but you did it 2 days later, obviously you didn't win the question because you didn't submit it early enough. Do we even care about cheaters like this, or do we just want to get them off the platform? Obviously there's no way to catch this in real time. We're probably going to have to do it retrospectively, running some sort of logic on the back end, maybe some cron job that runs every week to make sure that to clean up responses that are too similar to each other, or they're literally the same, or something like that. So we might also want to think about kind of cheaters, how to handle them, and what that is. Do we give them a kind of timeout from the next contests where they can't compete, or do we ban them directly? But what if our service is a paid service like LeetCode? Do we want to just ban them from the contest, or do we want to ban them from LeetCode entirely? These are things that we need to consider, because obviously people have paid money here. Maybe it's in the rules of the contest that if you get caught cheating, you'll lose your thing. But okay, that's just something to think about, right? People may have paid money to be on this site. I don't know why they're cheating, but people do weird things. Okay. Another thing that we want to consider on the UI is, okay, say you're typing and you're really close to being finished with a question, and then your internet dies or your computer crashes. What happens then? Do you lose all of your progress? That is another consideration that we can do, is how actually do we, let's see, save user progress, right? So I guess we have two options here, right? We can store it in the browser, and that's one option. Or we could potentially store this in the backend, which would make it a bit more complex, because, okay, now you have to store kind of the session, and you have to store the text that they've submitted so far. And then this brings the question of, okay, how often are you going to be saving it? Probably you don't want to be sending a request after each keystroke, because again, then there could introduce like latency. Then you have a problem with your code editor. If it's just sending too many requests, that might degrade the user experience. So maybe in this case, it's better to just store it to the browser. Of course, this does have the trade-off of, okay, if we do this, then, what happens if the user's cache of their browser gets cleared somehow, or they were doing this contest on Monday, they stopped, they couldn't do all the questions, they came back on Friday, and somehow they had cleared their cache, or something got evicted somehow, and now they've lost all of their progress. So there is a trade-off, right? There's no perfect solution here, but most likely, maybe we want to store it on the browser, because otherwise we have to keep sending requests to the server to save the current progress, and that might get too expensive, because now either we have to send it after each keystroke, which is very expensive and would probably be horrible experience for the user, because then you're just firing off a ton of requests. Or then we have to code in like logic into our component that, okay, if the user hasn't typed in 2 seconds, then save whatever they did, or after this many keystrokes, save what they did. So then you have to add all this complex logic, which might make the code editor a bit slower because it has to do all these checks. And then maybe there's a little bit of latency between the time the user presses a key and then it shows up in the code editor. So these are all things that you want to kind of consider. So it's not just like a simple UI. There's actually a lot of things behind the scene. And this is really kind of the questions you want to be asking and considering during your design. Obviously, you're not going to get everything off the bat. Some of these things will come to you as you're talking through your design. For example, I didn't even talk about this saving user progress thing until now. Things are kind of just going to flow through the interview, and you're going to speak to them when they kind of come up. Obviously, the main things you want to do is understanding the main functional requirements of the problem. You're going to want to make sure you're actually solving for what the interviewer wants, and then all of those like deep dives or whatnot can come later. And really, that's kind of where you're going to basically get the passing mark or not the passing mark is, okay, can you design the system, and also can you deep dive into the core components and talk about kind of the trade-offs there. So, okay, I have probably been talking for what is 40 minutes now. Hopefully I have been coherent enough throughout this entire time, but basically that is kind of in a nutshell how you want to approach one of these questions. Like I said, and we've done quite a lot here, right? We started with basically just listing out the requirements of our system. We talked about the SQL models, some trade-offs with supporting multiple languages, talked about kind of what the system could look like at a high level. We talked about some of the APIs. We also then discussed the UI. And I think one thing that I tried to do throughout this entire thing is always tie it back to the user experience. Because at the end of the day, with this interview, you're designing a system that people are going to use, and they're going to have some sort of experience with this system. And you also want to take that into consideration, right? Whereas when you design for system design, you really just want to make sure that it scales and that it can handle tons of data and that it's fault tolerant and all these other things. You're not really thinking about the end user itself. Whereas this interview, they relax the requirement on scalability and all of those really technical kind of database design and how you're going to shard your data and replicate it, and you're going to have multi-region data centers, and how are you going to, replicate the data across multiple areas, like all of that. They just relax that, but they want you to talk about the user and how your design decisions are going to affect them and be aware of them, right? Because at the end of the day, there's no right answer, but your choices still will impact the user, and you want to make the choices which make sense for the user, unless it would just really blow up the system where, okay, you could cater to the user exclusively, but then the system would be so bad on the back end that you're going to cause problems there. So again, like all things in software engineering, it's usually a trade-off. But okay, this is the second time where I've said, okay, I've rambled too much and talked too much. Hopefully you get the general gist of what you need to do here. Obviously, like I said, I've purposely left tons of gaps in this design. I've left a lot of things not spoken on, a lot of deep dives I didn't go into, for the purpose of stimulating you to actually think for yourself. And how would you approach this problem? What would you think about, did I maybe bring to light some things that you wouldn't have thought about, or the level of detail that you need to think about? Hopefully this video helps you. Anyway, if you made it to the end of me basically talking for 40 minutes straight and drawing boxes and things, then why not leave a like and a subscription to the channel? Would greatly help me out. You can also join the Discord, where you can ask me questions, interact with other people, and just join our community. If you want to become a channel member and support my work, then you can do so as well. I think there's a join button next to the subscribe button, completely optional. Do not feel obligated to do that. Otherwise, yeah, hopefully this video was helpful. Hopefully it stimulated your brains on what you need to do for these types of interviews. And yeah, thank you so much for watching, and I will see you in the next one. Bye.